Previously, I said that Microsoft's claim of a Majorana particle-based quantum integrated circuit would be either a stunning breakthrough or a huge embarrassment. The embarrassment would be largely in Satya Nadella giving a tour of interviews on this subject. It gets the full Microsoft PR treatment, including a highly produced video where the presenter talks slowly and clearly for us mere mortals to better understand the momentousness of this discovery. I hope what we're seeing is a genuine breakthrough. How could it not be? Well, I might not be able to tell you how to build a Majorana particle qubit, but I can tell you how it could all turn into liquid poop. First, there is some wiggle room in the claims. Yes, there is wiggle room. Microsoft's press release says, the Nature paper marks peer-reviewed confirmation that Microsoft has not only been able to create Majorana particles, which help protect quantum information from random disturbance, but can also reliably measure that information from them using microwaves. This seems airtight, no? Let's look at what Nature's editors say about the paper. Quote, the editorial team wishes to point out that the results in this manuscript do not represent evidence for the presence of Majorana zero modes in the reported devices. We're talking about the same paper here. How does an organization with as many very smart people as Microsoft has get out over their skis like this? The main problem is that it is so amazingly attractive if this is all true and it works. It really would be a roadmap to practical quantum computing as they claim, and that comes from the parts of the system that are easier to understand than Majorana zero modes. If the way that Microsoft has achieved constructing a qubit in fact works, it's all the stuff around it to read and write the data to and from that qubit that becomes much more usable and practical. It's not just, oh, we made a qubit, now we have to spend 15 or 20 years figuring out how to turn that into part of a computing machine. A lot of the practicality comes with the Majorana particle topological superconductor approach to making a qubit. That's what makes this invention potentially fatally attractive. I know Satya Nadella is not a condensed matter physicist or a materials scientist, but I'd like to think he spent the time and money to talk to a few potential skeptics. I hate to make the comparison because Elizabeth Holmes was knowingly a fraud from the very beginning, but the reason she got so much money to pursue what should have been obviously impossible is how very attractive it would be if it worked. It's not the invention itself, but the ability to put it to work and make money from it in the near future that makes people lose their minds when it comes to potential breakthroughs.